Hi everyone and welcome to MathSux. This video is going to help you pass the Geometry Common Core Regents. We're doing this one question at a time. Here is part 3 with question 32. Modeled by right triangles below, a surveyor S is taking land measurements using a cabin C, a boulder B, and tree T as fixed points of reference. The cabin, boulder, and tree are collinear. The surveyor is 917 meters from the cabin, 1,048 meters from the boulder, and 1,425 meters from the tree. Determine and state to the nearest degree the measure of angle BST. So angle BST. So we're looking for this angle right here. So this is going to be a SOHCAHTOA problem with trigonometry, trigonometric functions. Our main process for answering this question is we're trying to find this angle right here. But notice we have two right triangles that we can work with. We have this big one, triangle SET, and then the smaller one, triangle SCB. So if we can find the angle of this big triangle and this little triangle, we can subtract the smaller one from the bigger one and be left with this angle BST. So if that doesn't make sense, it's okay. We're going to do this one step at a time. So let's first start by drawing out these two triangles separately. So I'm going to draw out this big one. So we're looking at this angle right here in triangle SCT, and they gave us another value here, right? We have the hypotenuse 1425 meters, and then we have this leg 917 meters. In reference to this angle S over here, we have the hypotenuse and we have the adjacent. And when we look at SOHCAHTOA, which trig function has the hypotenuse and the adjacent? And that's cosine. So what we're going to do is cosine of, I'm going to call it x degrees, so this whole thing will be x, is equal to the adjacent 917 over the hypotenuse 1425. And so to find a missing angle, we're just going to go second cosine, and you get like this kind of -1 of 917 over 1425. And when we do that, we get 49.94. So this entire thing, this angle x here, for this big triangle is equal to 49.9460. Okay, so that's the first part of this question. Now let's find this angle in here of the smaller triangle. So let me draw out the smaller right triangle. Here we have C, B, and S again. And we're finding this angle. And this time we have 917 again, 917 meters on this leg. And then for the hypotenuse, it's a different hypotenuse. We have 1048 meters. So we have the hypotenuse, and we have the adjacent again. So we're going to be using cosine again, hypotenuse and adjacent. So cosine of, well, let's call this y degrees. Cosine of y degrees is equal to the adjacent 917 over the hypotenuse 1048. So we'll do the same thing. Cosine to the -1, and this will be 917 over 1048 on the calculator. Let's plug this in. And we get 28. So this little portion up here is equal to this 28.9. Okay, so now our last step for answering this question is to remember we were trying to find this. So now that we have this whole angle and this little piece of this angle, we can take this and subtract it from the whole. So we're gonna do that 49.94 minus the angle we just found. So let's plug that in. And we're left with 20.99. And if you look back, remember they always want this rounded to something. They wanted it to the nearest degree. So this is going to be rounded to 21 degrees. And that's our answer. So this right here is 21 degrees. Question 33. A garden bed pictured below is a square prism with a rectangular prism taken out. The inside length of the square prism is 6 feet. The rectangular prism taken out has a width of 2 feet and a length of 4 feet. The diagram below shows the top view of the garden bed with its inside measurements. The garden bed is filled with topsoil to form a uniform height of 1.25 feet. And then we have 2 questions. This is like A. Determine and state the volume of the topsoil in cubic feet. So we're looking for the volume of this shape. And with this we have to be careful because they label it for us, but they kind of leave out this height of the rectangular prism with the rectangular prism taken out. So I'm gonna redraw what this kind of looks like. So I'm gonna kind of ignore the hole in the middle for now, and I'm just gonna draw a rectangular prism of what this would be like if there was no hole. So here's our rectangular prism where one side is 6 feet. And then if you look at this, it's actually a square prism, right? Because this all adds up. This, if you look at the whole length of this is 2 plus 2 plus 2. So this is also 6 feet. So this is 6 feet by 6 feet by 6 feet. So this is a square prism. And then the height, which they don't picture here, is 1.25 feet. So if we wanted to find the volume of this shape, it would be 6 times 6 times 1.25. which is 45. So be careful here because that's not our answer. This is just the entire volume of the whole square prism as if there wasn't a hole in it. But we need to account for the hole. So what we're going to do is find the volume that would be in here, this rectangular prism that is taken out. So the rectangular prism within the square prism. So this is the hole, and then this is like the piece in here. So if we look at this is going to be 4 by 2, and then the height is going to be the same thing, 1.25. So the volume of this rectangular piece that's taken out over here is going to be 4 times 2 times 1.25, which is 10. So now to find the volume of just this shape, which is what we're looking for, we're going to do 45 minus that piece, which we're taking out, minus 10, which is 35 feet cubed. So that's our answer for part A. So this could be a little hard to visualize, so make sure to draw diagrams and just be careful and make sure you read everything because you might miss that 1.25 feet. Okay, the next part of this question says each bag of topsoil sells for $3.68 and contains 2 cubic feet of topsoil. Determine and state the total cost of the bags of topsoil that must be purchased to fill the garden. Is take the volume we found, 35, divide it by 2 cubic feet, right? 35, so we have 35 divided by 2. So that means 17.5, that means we're going to need 17.5 bags of soil. That's what we're going to need to fill this space. So you can't get 17.5 bags though. So what we're going to do is round up to 18 bags. So that means we're going to purchase 18 bags and they cost $3.68 each. So we're going to do 18 times 3.68 just to get the total. So we have 18 times 3.68 and this total comes out to 66.24. So it tells us 2 cubic feet are in each bag. So we just figured out like how many, based on the volume we found in the previous question, how many bags are we going to need? And then based on that, how much is it going to cost? So we figured out we're going to need 18 bags because you can't get 17.5 bags. And 17 bags would not be enough, so we have to round up. So multiply that times the price of each bag and we get $66.24. And that's our answer. Question 34. Given triangle ACD with line ABC and line AED, and given that BE is parallel to CD. Let's write this down. BE is parallel to CD. Prove AB times AD is equal to, so AB over here times AD over here is equal to AE times AC. What we're gonna need to do here is prove that triangle ABE, so there's two triangles here, this small triangle ABE, and then this big triangle ADC. We're gonna need to prove that these two triangles are similar by angle, and then set up a proportion which will cross multiply to prove this is true. So I'm just gonna, let me just draw out these two triangles more clearly what we're doing. So we have ABE in here, and then we have this bigger triangle ACD, right? They share this angle A. And then because these are parallel, which was given to us, we know angle B is going to be congruent to angle C, right? Because it creates that corresponding angle relationship that you find with parallel lines that are being cut by a transversal. In this case, the transversal is like ABC. And we also have equal angles on this other side with angle E and angle D. So once we prove them similar by angle, and we can set up a proportion, which we can then cross multiply and prove this is true. So if this doesn't make any sense yet, don't worry, we're gonna do this one step at a time. So first, let's start off with writing our statements and reasonings. And when doing any kind of proof, you always want to start with what's given to us. So we're just going to rewrite what they gave us up here. And the reasoning for that is that it's given. And now we can talk about the angles already. So we can say angle ABE is congruent to angle ACD. And we can also say the other pair of angles are congruent to each other. Angle AEB is congruent to angle ADC. And this is based on corresponding angles. That are formed when a parallel lines are cut by a transversal. So we said, which was all stated in the given already, so we don't need to explain that any further. Okay, next we can actually, because we stated these angles are congruent, we can state that these two triangles are similar to each other. So you could say triangle ABE is similar to triangle ACD, and this is by angle. And because of that, now we can form that proportion that will ultimately form this. So let's say AB, this side here, over AC is equal to AE over AD. And the reasoning for that is corresponding sides of similar triangles are in proportion. And now we can do that cross multiplying. So you could see if we cross multiply this, we'll get AB times AD is equal to AE times AC. And the reasoning for this is product of the means equals product of the extremes. And that's our answer. Question 35, our last question. Triangle PET has vertices with coordinates -6, 4, 6, 8, and -4, -2. Prove triangle PET is a right triangle. So here, It says the use of the axis on the next page is optional, so I'm gonna use it. So let's separate these two pages. And for now, I'm just gonna fold this in half. So let's graph this. We have -6, 4. So we want to prove that this is a right triangle, and the way to do that is by finding the slope and making sure that we have negative reciprocals of each other. So we're going to be wanting to find the slope of each side and look for the negative reciprocals. So that'll prove that there's a right angle there. So let's first find the slope between points P and E. So P is -6, 4. And E is 6, 8. So to find the slope, we're just doing that slope formula, y2 minus y1 over x2 minus x1. So we get 1/3. So I'm just going to put that over here. Slope is equal to 1/3 here. Okay, so now let's find the slope between P and T, where P is -6, 4. And T is -4, -2. And we'll do that same slope formula. So here we get -3. So the slope here is -3. So notice these are negative reciprocals of each other. We have 1/3, and then if we flip and negate it, we get -3. So we know that there's a right angle here, and we know that this is a right triangle. Let's just find the last slope to make sure we're correct and there isn't anything funky going on here. So I'm gonna do the last slope. T is -4, -2, and E is 6, 8. Using that same slope formula. So we get 1 here. So the slope here equals 1. So yes, this is a right triangle because of those negative reciprocals, so we're just going to write a little sentence. So we said, since the slopes of PE and PT are negative reciprocals of each other, that means they form a perpendicular line at 90 degrees, forming a right triangle. Okay, so that takes care of part 1. Let's now look at part 2 of this. So I'm just going to slide this up. So this next part of this question says, state the coordinates of N, the image of P. So we're going to be doing something to P after a 180 degree rotation centered at 1, 3. So 1, 3 is over here. So this is going to be a rotation point of point P. So P is over here. So if we're rotating about this point, we want to get, so here's point P, here's our point of rotation. We want to get point P in terms of this point of rotation, as if it's the new origin. So we're going to kind of pretend this is an origin and a new coordinate plane, and we're going to see where P falls within this. In relation to this point of rotation, P is at, so pretending this is an x-axis stemming from here, 1, 2, 3, 4, 5, 6, 7. So we have -7, and then we go up 1. So -7, 1. So in relation to this point, P has the value -7, 1. And when it's saying that it's going to be a 180 degree rotation. So when we do a 180 degree rotation, what we end up doing, the rule for that, we end up negating the x and y. So our new P p prime is going to be negating the x and y, so that negative 7 was going to become positive 7, and that positive 1 is going to become negative 1. So if we map out this new point, and again, remember, this is in relation to this point of rotation. This isn't from the origin. So if we map out this new point in relation to the rotation, let's see what we get. So we get 1, 2, 3, 4, 5, 6, 7, and then minus 1. So our new point P is over here. So I'm going to label this P prime. So now it still tells us to state the coordinates of n. Oh, so we're actually going to call this n. So n, before we say this is our answer, 7, negative 1, remember this is in relation to that point of rotation, 1, 3. So we need this new point in relation to the origin, the real origin over here. So our new point n in relation to this point, let's see where that is. 1, 2, 3, 4, 5, 6, 7, 8, and then up 2. So 8, 2 is our answer for this second part of this question. Okay, so we're almost done. There's one more part to this question. We need to prove PENT is a rectangle. So that new point that we just found, PENT. So let me mark this. So now we're going to say PENT is a rectangle. So we want to prove that this shape, let me outline the whole thing so it's easier to see. So in order to prove this is a rectangle, there are a couple of things we're going to need to do. We want to first prove that this is a parallelogram by showing opposite sides are parallel, and then we're going to need to prove that it has right angles all around in each corner. So we already did this one, but we need to do the other 3. So 2 things: prove opposite parallel sides, and then 2, we're going to need to prove 90-degree angles all around in all 4 corners. Okay, so to prove opposite parallel sides, we're going to be finding the slopes again. So already we found this slope. We know this is 1/3 PE. We know this is -3. And now we're going to have to find the other slopes EN and TN to prove that they're equal to the other side. So we want side TN to be equal to 1/3, and we want side EN to be equal to -3. So let's find the slope of EN, where E is 6, 8, and N is 8, 2. And we're using that slope formula again. y2 minus y1 over x2 minus x1. And we end up getting -3, which is exactly what we wanted, right? And the slope is equal to -3. Okay, good. Now let's find the slope of Tn. So T is -4, -2, and N is 8, 2. Okay, good. This also is equal slopes on the other side. So they're equal slopes, and they're both negative reciprocals of each other. So actually finding this information checks off everything we needed to do. So now we just need to list everything out. Now we need to write our story. So since the slopes of PE and TN are equal, then PE is parallel to TN. And now we're going to write the same thing for the other 2 sides. And now we could say that this shape is a parallelogram. since the opposite sides are parallel, which we just stated, PENT is a parallelogram. So this is all proving this is a parallelogram. And now we're going to prove that it's a rectangle. So here we could just say, since angle P is a right angle, PENT is a rectangle. So we know that because of the slopes are negative reciprocals of each other, which we stated in the first part of the question. And because we stated this over here, we already know that it's a parallelogram and that opposite sides are parallel. Because there's one right angle, there's going to be other right angles all around. So that's our answer. So I hope you found this helpful. If you have any questions, please let me know in the comments. Good luck and happy calculating!